gas furnace can indeed be considered a motor-operated appliance due to the presence of several key components that rely on electric motors for their operation. The primary motor is the blower motor, which is responsible for circulating air throughout the ductwork of a building. This motor drives a fan or blower wheel, forcing heated air into the living spaces and drawing cooler air back to the furnace for reheating. This air circulation is essential for maintaining a consistent and comfortable temperature within the building. In addition to the blower motor, many gas furnaces also incorporate a direct vent chimney motor. This motor is typically a smaller fan that assists in exhausting combustion gases safely outside the building. Direct vent systems are designed to prevent the backdraft of harmful gases such as carbon monoxide into the living space. The vent motor ensures that these gases are properly expelled, contributing to the overall safety and efficiency of the furnace. While the blower motor and vent motor are the primary motor-driven components, it's also important to consider the other electrical elements of a gas furnace. The ignitor, for example, is an electrical component that initiates the combustion process. It heats up to a high temperature to ignite the gas, starting the heating cycle. The control circuit is another crucial electrical system that regulates the operation of the furnace. This circuit monitors various sensors and safety devices, controlling the timing and sequencing of different components. It ensures that the furnace operates safely and efficiently, responding to changes in temperature and other parameters. Considering these factors, the classification of a gas furnace as a motor-operated appliance is justified. The presence of the blower motor and, in many cases, a direct vent chimney motor clearly indicates that the furnace relies on electric motors to perform its essential functions. Although the ignitor and control circuit are also important electrical components, it is the motors that directly contribute to the movement of air and the exhaust of gases, solidifying the furnace's status as a motor-operated appliance. To elaborate further, the blower motor's role in a gas furnace is analogous to the heart in a circulatory system. Just as the heart pumps blood throughout the body, the blower motor circulates heated air through the building. Without this motor, the heat generated by the furnace would remain localized and ineffective in warming the entire space. The blower motor's size and power are determined by the size of the building and the capacity of the furnace. Larger buildings and higher capacity furnaces require more powerful blower motors to ensure adequate air circulation. The direct vent chimney motor, when present, plays a critical role in maintaining safe indoor air quality. By actively exhausting combustion gases, it prevents the buildup of dangerous levels of carbon monoxide. Direct vent systems are particularly important in tightly sealed buildings where natural ventilation is limited. The vent motor ensures that the combustion gases are properly vented to the outside, regardless of weather conditions or other factors that could affect natural draft. The ignitor is an essential component for initiating the combustion process. In older furnaces, a pilot light was used to continuously burn a small amount of gas, providing a flame to ignite the main burner. However, modern furnaces typically use electronic ignitors, which are more energy efficient and safer. These ignitors use electricity to heat up a resistance element, creating a spark or a hot surface that ignites the gas. The control circuit is the brain of the furnace, monitoring and regulating its operation. It receives input from various sensors, such as thermostats, flame sensors, and pressure switches, and uses this information to control the timing and sequencing of different components. For example, the control circuit will turn on the blower motor after the burner has been ignited and reached a certain temperature. It will also shut down the furnace if it detects a problem, such as a flameout or an over-temperature condition. The control circuit is essential for ensuring that the furnace operates safely and efficiently. In summary, a gas furnace is indeed a motor-operated appliance due to its reliance on electric motors for essential functions such as air circulation and exhaust ventilation. While other electrical components like the ignitor and control circuit are also important, it is the blower motor and vent motor that primarily define the furnace as a motor-operated appliance. These motors directly contribute to the movement of air and the safe exhaust of gases, making them integral to the overall operation of the furnace. Now let's delve into some specific technical aspects of these motors and related components. The blower motor in a gas furnace is typically an induction motor, which is known for its reliability and efficiency. Induction motors operate on the principle of electromagnetic induction, where a rotating magnetic field induces a current in the rotor, causing it to turn. These motors are available in various speeds and horsepower ratings, depending on the size and capacity of the furnace. The speed of the blower motor is often controlled by a multi-speed switch or an electronic speed controller, allowing the homeowner to adjust the airflow based on their needs. The direct vent chimney motor is usually a smaller, shaded pole motor or a brushless DC motor. Shaded pole motors are simple and inexpensive, but they are less efficient than brushless DC motors. Brushless DC motors offer higher efficiency and longer lifespan, but they are more expensive. The choice of motor depends on the specific design and requirements of the furnace. The igniter in a gas furnace can be either a hot surface igniter or a spark igniter. Hot surface igniters use a resistance element that heats up to a high temperature, while spark igniters use a high voltage spark to ignite the gas. Hot surface igniters are more common in modern furnaces, as they are more energy efficient and reliable. The control circuit in a gas furnace is typically a printed circuit board PCB with various electronic components such as microcontrollers, sensors, and relays. The microcontroller is the central processing unit of the control circuit, responsible for monitoring the sensors and controlling the other components. The sensors provide input to the microcontroller, such as temperature, pressure, and flame status. The relays are used to switch on and off the various components such as the blower motor, igniter, and gas valve. The control circuit is designed to ensure that the furnace operates safely and efficiently, responding to changes in temperature and other parameters. Furthermore, it's worth noting that the energy efficiency of a gas furnace is often expressed as its annual fuel utilization efficiency, or a FU rating. The FU rating represents the percentage of the fuel's energy that is converted into usable heat. Higher FU ratings indicate more efficient furnaces, which can save homeowners money on their energy bills. Modern gas furnaces often have FU ratings of 90% or higher, meaning that they convert 90% or more of the fuel's energy into usable heat. The efficiency of the blower motor and vent motor also contributes to the overall energy efficiency of the furnace. More efficient motors consume less electricity, reducing the overall energy consumption of the appliance. In addition to energy efficiency, safety is a critical consideration in the design and operation of gas furnaces. Furnaces are equipped with various safety devices to prevent hazards such as gas leaks, carbon monoxide poisoning, and overheating. These safety devices include flame sensors, pressure switches, and high limit switches. The flame sensor monitors the presence of a flame in the burner, and if the flame is not detected, it shuts off the gas valve to prevent a gas leak. The pressure switch monitors the pressure in the vent system, and if the pressure is too low, it shuts off the furnace to prevent the backdraft of combustion gases. The high limit switch monitors the temperature of the furnace, and if the temperature is too high, it shuts off the furnace to prevent overheating. These safety devices are essential for ensuring the safe operation of the furnace. In conclusion, a gas furnace is undoubtedly a motor-operated appliance due to the critical roles played by the blower motor and, in many cases, the direct vent chimney motor. These motors are responsible for circulating heated air and safely exhausting combustion gases, respectively. While other electrical components like the igniter and control circuit are also important, it is the motors that primarily define the furnace as a motor-operated appliance. The design, operation, and safety features of these motors and related components are essential for ensuring the efficient and safe heating of buildings. Now, let's discuss some common maintenance practices for gas furnaces, particularly those related to the motor-operated component. Regular maintenance is crucial for ensuring the efficient and safe operation of a gas furnace. Neglecting maintenance can lead to reduced efficiency, increased energy consumption, and even safety hazards. One of the most important maintenance tasks is to regularly inspect and clean the blower motor. Over time, dust and debris can accumulate on the blower motor, reducing its efficiency and potentially causing it to overheat. The blower motor should be cleaned at least once a year, and more frequently if the furnace is located in a dusty environment. To clean the blower motor, first turn off the power to the furnace. Then, remove the blower motor from the furnace and use a brush or vacuum cleaner to remove any dust and debris. Be careful not to damage the motor windings or other components. Another important maintenance task is to lubricate the blower motor bearings. Some blower motors have seal bearings that do not require lubrication, while others have bearings that need to be lubricated periodically. If the blower motor has lubrication ports, use a lightweight oil to lubricate the bearings. Be careful not to over-lubricate the bearings, as this can attract dust and debris. The direct vent chimney motor, if present, should also be inspected and cleaned regularly. Like the blower motor, the vent motor can accumulate dust and debris over time, reducing its efficiency. The vent motor should be cleaned at least once a year, and more frequently if the furnace is located in a dusty environment. To clean the vent motor, first turn off the power to the furnace. Then, remove the vent motor from the furnace and use a brush or vacuum cleaner to remove any dust and debris. Be careful not to damage the motor windings or other components. In addition to cleaning and lubricating the motors, it is also important to inspect the other electrical components of the furnace, such as the igniter and control circuit. The igniter should be inspected for cracks or damage and replaced if necessary. The control circuit should be inspected for loose connections or corrosion and cleaned if necessary. It is also important to have the furnace inspected annually by a qualified HVAC technician. The technician can perform a more thorough inspection of the furnace, including checking the gas pressure, testing the safety devices, and cleaning the burner. Regular maintenance can help to extend the lifespan of the furnace and prevent costly repairs. Finally, let's consider some troubleshooting tips for gas furnaces, focusing on issues related to the motor-operated components. If the furnace is not producing heat, there could be a problem with the blower motor, the vent motor, the igniter, or the control circuit. If the blower motor is not running, check the circuit breaker or fuse that supplies power to the furnace. If the circuit breaker is tripped or the fuse is blown, reset the circuit breaker or replace the fuse. If the blower motor is still not running, there could be a problem with the motor itself. Use a multimeter to check the voltage to the motor. If there is no voltage, there could be a problem with the control circuit or the wiring. If there is voltage to the motor may be faulty and need to be replaced. If the vent motor is not running, check the wiring and connections to the motor. If the wiring is loose or corroded, tighten or clean the connections. If the vent motor is still not running, there could be a problem with the motor itself. Use a multimeter to check the voltage to the motor. If there is no voltage, there could be a problem with the control circuit or the wiring. If there is voltage to the motor may be faulty and need to be replaced. If the igniter is not working, check the wiring and connections to the igniter. If the wiring is loose or corroded, tighten or clean the connections. If the igniter is still not working, there could be a problem with the igniter itself. Use a multimeter to check the voltage to the igniter. If there is no voltage, there could be a problem with the control circuit or the wiring. If there is voltage to the igniter may be faulty and need to be replaced. If the control circuit is not working properly, it can cause a variety of problems with the furnace. If the furnace is not responding to the thermostat, there could be a problem with the control circuit. If the furnace is shutting down prematurely, there could be a problem with the control circuit. If the furnace is displaying an error code, consult the furnace's manual for troubleshooting information. In many cases, problems with the control circuit require the assistance of a qualified HVAC technician. These troubleshooting tips can help to identify and resolve common problems with gas furnaces, particularly those related to the motor-operated component. Remember to always turn off the power to the furnace before attempting any repairs or maintenance. If you are not comfortable working with electricity, it is best to consult a qualified HVAC technician.